This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on solving systems with inverse matrices. Our first question is the system x plus 3y equals -1 and 4x minus 5y equals 13. We want to find a point xy common to both lines. Let's rewrite this system as a matrix equation. So the coefficients 1, 3, 4, -5 make up this first matrix. The variables x, y make up the second one, and the solutions -1, 13 make up the third. Notice, multiply the rows to the columns. 1x plus 3y would equal -1. 4x plus -5y equals 13. So we've rewritten this equation in matrix form. We want to label these matrices. This first matrix we're going to call A. This matrix composed of the variables x and y is the vector x, or the 2x1 matrix x, and the solution matrix -1, 13 will be the matrix B. And our goal is to solve for the matrix x, and there is no such thing as matrix division, so we can't just take vector B divided by matrix A. We have to think about how the inverse matrices are going to be used. So we start with AX equals B. Again, our goal is to solve for A. We're going to multiply on the left side by A inverse. It's very important that's on the left side because matrix multiplication is not commutative. So multiply on the left side here, multiply on the left side here. We have A inverse times AX equals A inverse times B. Associative property does hold. A inverse times A can be associated together times X equals A inverse B. But A inverse times A is the identity matrix. So we have the identity matrix I, in this case a 2x2 identity matrix, 1, 0, 0, 1. Ix will equal A inverse B, and the identity matrix times X is just X. So this matrix inverse strategy will require us to find the inverse of this matrix A, so we'll find A inverse, and then multiply it by this matrix B, -1, 13. So there's our matrices A, X, and B. We want to find A inverse, so we first need the determinant. Starting up here, 1 times -5 is -5. 4 times 3 is 12. -5 minus 12 is -17. That is the denominator of all 4 slots for our inverse matrix. So A inverse starts with this. Denominator is the determinant. -17, -17, -17. Switch the two numbers on the main diagonal. So -5 comes up here, 1 goes down there in terms of our numerators. And then you change the signs of the off diagonal. So +3 becomes -3, +4 becomes -4. That's our quickest way to evaluate the inverse matrix. And then let's simplify this. Of course, a negative divided by a negative is a positive, so these 3 things will all be positive, and then this will be -1/17. So we have matrix A inverse. Now, we said earlier that X is A inverse B. So we're going to need to take this matrix A inverse and multiply it by this matrix B to get this X, which of course is XY. So that's our big fact. X is A inverse B that we proved in our development on the earlier slide. So our vector X is XY, A inverse is here, and that is our vector B. So rows to columns, 5/17 times -1, -5/17. 3/17 times 13 is 39/17, so we have -5/17 plus 39/17. On the bottom, -4/17 minus 13/17. And you'll see that these numbers turn out very nice. 39/17 minus 5/17. So you'll notice that these answers both turn out nice. 39 minus 5, 34/17. -4 plus -13, -17/17. Which of course is just going to give us 2 and -1. And let's check that. 2, x is 2, 3 times -1 is -3, 2 plus -3 is -1, check. 4 times 2 is 8, -5 times -1 is -5, 8 plus 5 is 13, check. So we consider our solution to be the point to -1, and I use the curly braces because it's a set of solutions. It's a set that only has one value, but that indeed is a solution set for this system of equations. Now for this problem, the inverse strategy is really sort of nice. So we're going to rewrite this as a matrix equation. So we get 2x plus 5y is 9, 3x minus 4y is 1. This, of course, is the matrix A, this is the matrix X, and that's the matrix B. And we know how to solve for X. Again, there is no such thing as matrix division, so pre-multiplying by A inverse A is I, so IX is X, X is A inverse B. So we find the inverse of this matrix A and multiply it by the matrix B to get the matrix X. The matrix X consists of the X value and the Y value. So there's our A, X, and B. We want to find A inverse, we need the determinant. How do we get the determinant? 2 times negative 4, negative 8. 3 times 5 is 15. Negative 8 minus 15, negative 23. And for our inverse matrix, that will be the denominator for all 4 slots. To find the numerator, we switch the numbers on the main diagonal, so negative 4 will come up here and 2 will go there. And change the sign on the off diagonal. So 5 will become negative 5, 3 will become negative 3. So that's our shortcut way to find an inverse of a 2 by 2 matrix. Of course, negative over negative is positive, so let's rewrite this in that form. So we have A inverse is 4 23rds, 5 23rds, 3 23rds, and negative 2 23rds. You could check it by multiplying it by A. Of course, A times A inverse or A inverse times A has to be the identity matrix 1 0 0 1. But to go ahead and solve this system, we're going to take this matrix A inverse and multiply it by B. So there's all our information, A, X, B, and A inverse. And we know X is A inverse times B. Make sure you're multiplying it in the correct order. This goes on the left, B goes on the right. So let's think about this. We have 4 times 9, 36 23rds. 5 times 1, 5 23rds. And then we have 3 times 9 is 27 23rds minus 2 times 1 minus 2 23rds. 36 and 5, 41, 41 23rds, 27 minus 2, 25 23rds. And you'll recognize that was actually relatively easy. So using the matrix inverse strategy when you have fractional solutions is certainly one of the better strategies you could choose. So our final solution, X is 41 23rds, Y is 25 23rds, and I like to use the curly brace notation to indicate that that is a solution set. Let's look at another one. 5x plus 2y is negative 3, and x minus 4y is 17. We need to rewrite this as a matrix equation, so we'll do that first. Matrix A times x equals b. Again, 5x plus 2y is negative 3. 1x minus 4y is 17. So there's matrix A, there's matrix X, there's matrix B. And again, our solution will be x is A inverse B as long as A inverse exists. So to find A inverse, we will take the determinant of that matrix and make that the denominator of all 4 slots. So the determinant of A, 5 times negative 4, negative 20 minus 1 times 2 is 2. Negative 20 minus 2 is negative 22. That will be the bottom of all 4 slots in our inverse matrix. Switch the numbers on the main diagonal. Negative 4 and 5 will switch places. And change the signs of the off diagonal. 2 becomes negative 2, 1 becomes negative 1. And then simplify this fraction. Negative 4 over negative 22 would be 2 elevenths. Negative 2 over negative 22 would be 1 11th. Negative 1 over negative 22 is 1 over 22, and 5 over negative 22 is negative 5 over 22. So we have this A inverse matrix. To get our solutions, x, y, we'll take the A inverse and multiply it by B. So we take this matrix, multiply it by negative 317, must multiply it on the left because matrix multiplication is not commutative. So there's all our information. Again, x is A inverse times B. X is the matrix xy. A inverse 2 elevenths, 1 11th, 1 22nd, negative 5 22seconds times negative 3, 17. So 2 elevenths times negative 3 is negative 6 elevenths. 1 11th times 17 is 17 elevenths. So 17 elevenths minus 6 elevenths is a nice number. 1 times negative 3, negative 3 22seconds. Negative 5 over 22 times 17, negative 85 22seconds. That also is a pretty nice number. So look at how this is going to work. 17 minus 6, 11 over 11. Negative 85 plus negative 3, negative 88 over 22. This reduces to 1, and that reduces to negative 4. So it sure looks like Our solution here is 1, negative 4. But let's check it. 5 times 1 is 5. 2 times negative 4 is negative 8. 5 plus negative 8 is negative 3. Check. 1 minus 4 times minus 4 is 16. 1 plus 16 is 17. Check. So that looks pretty good. So we're able to solve that problem also using our matrix inverse strategy. Let's look at one more. So I have x plus 4y is negative 5 and 3x plus 12y is 1. Our matrix A is, of course, the coefficients to the left of the equal sign. That'll be 1, 4, 3, 12. And our matrix B would be here, would be negative 5, 1. And our answer, xy, should be A inverse B. But what is A inverse? To answer that question, we've got to take the determinant of A. 1 times 12 is 12. 3 times 4 is 12. The determinant of A is 12 minus 12, which is 0. And normally speaking, that would be the denominator of all 4 slots, but you cannot divide by 0. In fact, if the determinant is 0, the matrix does not have an inverse. So if there is no A inverse, you cannot use this matrix inverse strategy. So use one of your other strategies like Gaussian elimination with back substitution, elimination of variables, and you will find that you will get an entire row of zeros, and you'll have to express your solution parametrically. But the matrix inverse strategy does not work if there is no matrix. And that will conclude this lesson.